Hey y'all, welcome to your Algebra 2 Lesson 2.5, 2.6. In video 1, we'll talk about 2.5, in which you will learn how to model direct variation. And then in video 2, we will talk about 2.6, which is making scatter plots and best fitting lines. Alright, 2.5 is about direct variation. It's a special type of linear function. The equation y equals ax represents direct variation between x and y is said to vary directly with x. The non-zero constant a is called the constant of variation. The graph of y equals a times x is aligned with the slope a and a y-intercept at the origin. So your slope is a and your y-intercept is at 0, 0. For example 1, we're going to write and graph a direct variation equation that has negative 3, 2 as a solution. Now, we know an x and y value here, and we can use that to find the constant of variation because it has to be true for every xy pair. So what we're going to do is we're going to use y equals a times x, and we're going to plug in the specific x value we have for x and the specific y value we have for y and solve for a. So 2 equals a times negative 3 because y is 2 and x is negative 3. So we substituted 2 for y and negative 3 for x. And then we're going to solve for a. So a is being multiplied by negative 3, so we're going to divide both sides by negative 3 and we get negative 2/3 equals a. And so our equation for direct variation would be y equals negative 2/3 x. So you're going to have one point at the origin because these always go through the origin, and then one point at negative 3, 2, and that is going to give you your graph. Example 2. Write and apply a model for direct variation. According to Hooke's law, the force that is needed to stretch a spring varies directly with the amount the spring is stretched. If 64 pounds of force F stretches a spring a distance d of 8 inches, write an equation that relates F and D. Well, F is going to equal A times D. So that's our direct variation equation. So 64 equals A times 8 because we've got 64 pounds of force, so that's our F value. And we have a distance of 8 inches is our D value. We divide both sides by 8. 64 divided by 8 is 8. So that's going to be our constant of variation. So an equation that relates F and D is F equals 8 times D. Predict the amount of force that is needed to stretch the spring to 14 inches. Okay, so that's a distance, so we're going to substitute that in for D. To stretch the spring, D equals 14 inches. The amount of force needed is F equals 8. That's our A value times 14. That's our specific D value, and that gives us 112 pounds. All right, we're going to use ratios to identify a direct variation because if you have a direct variation, then the ratio of one variable to the other should remain constant throughout all your ordered pairs. The table below gives sample cell phone bills showing the total monthly cost and the number of minutes used that month. Tell whether the total cost and the number of minutes shows direct variation. If so, write an equation that relates the quantities. So we're going to look at the ratio of cost to minutes, so C over M. So we've got 35 over 100 is 0.35. We have 45 over 129 using the next ordered pair, and that's approximately 0.35. Then we move to the next ordered pair. We have 80 over 229, and that rounds to be 0.35. Then we have 15 over 54, which rounds to be 0.34, but that's really close to 0.35. And then we've got 30 over 86, which rounds to be 0.35. So this does appear to be a direct variation because the ratios are approximately equal. So we can model this. We know that C over M is equal to 0.35. We multiply both sides by M. We get C equals 0.35 times M. All right, that's it for 2.5. I'll meet you back here in the next video, and we will talk about scatter plots and best fitting lines.